This is a brief overview of a part that I received over the weekend. This is a tractor impeller. So this is used in a blower system on a large farm tractor. So the issue here is repair or new. So the two options are look at the existing damaged part and try and understand what happened, what needs to be done, how much work it's going to involve, versus measuring the part carefully and fabricating completely new parts and weld up a completely new unit. Now, the issue here is there is a price threshold. The new part itself is $250. So, in order for this to be a viable repair, it has to come in at 200 or under for the client to make this acceptable. And for me, the time invested in the project needs to be such that the $200 is a worthwhile investment of my time to actually make a profit. So we're going to look at this part and kind of understand what went on here. So this is a view of the impeller from the top. And as you can see by the inserted red line, that at least one of the blades has been bent way out of alignment with the other ones. Since there are six, they are following a pretty understandable angular measurement of 60 degrees radiating out from the central hub. Turning this impeller over, you can see that once all the dirt was cleaned off, there are quite distinct visible cracks evident in the top, which means that if these are visible cracks, one thing to think about is what about the cracks that are not visible? So these cracks could in fact completely circle the hub in the center, and they may not have made it all the way to the surface and become visible. So if there are some cracks visible, most likely there are many more that you can't see. These are the kind of things that only be revealed through something like a dye penetrant test, or even better yet, like a magnetic particle test, which will allow seeing the cracks that are under the surface and not having penetrated through the oxide layer at the top. Here's a view from the side. And again, looking at the red line, you can see that the impeller itself is not flat anymore. And the client had stated that under load, the impeller was vibrating quite badly and shaking the entire machine in quite a bad way. So things to watch out for here are that the vibration that was transmitted from the bent impeller is transmitted through the shaft to the gearbox and the rest of the machine. So the client is going to be looking at the gearbox of the tractor at the PTO, which is the power takeoff, in order to see if there's any damage that's been transmitted from the damaged impeller, which is rotating at high speed, to the gearbox, such as an ovaled or damaged bearing or possibly a bent shaft. In this view from the side, you can see comparing one of the straight impeller vanes versus one of the bent ones. You can see just how far bent off it is and how much it has warped the bottom of the plate that makes the base of the impeller. So one of the concerns here is that even if this blade were heated up and then forged back into place, that really doesn't do anything to heal cracks that are in the material itself or fatigue stresses that are in the material. So you could bend it back, weld it in place, and very well have this thing come flying apart the minute it encounters a small rock or a large branch or something that may hit it. So that's one of the my concerns with repairing a damaged piece like this, because it may look repaired but not necessarily be repaired. And also trying to flatten that disc at the back may be an incredible amount of work without access to a very large press and a very large base plate in order to flatten it too. The two arrows are pointing out quite obvious cracks where the existing weld against the central hub was broken by the impact. And if you look at the lower arrow, you can see that's pointing to the very beginning of the crack, or maybe the end of the crack, you could say. So again, one of the concerns is how far does that crack actually go? You can see where it goes into the base plate and probably continues further along there, but you can't see it. So if this were to be welded out, this would have to be completely V'd on both sides all the way down. So the question is it possible to get a tool in there? Since it's such a small cramped space, most likely the only tool to get in there would be a carbide burr, which would probably be a lot of work and very difficult to get in there without either making a very messy groove or possibly even breaking the burr, trying to jam it into the corner. And burrs are not cheap, so this has to be factored into the cost of the repair. Do I want to sacrifice a $20 or $30 carbide burr getting down in there? Because that means that's not profit. I'm losing that money. So another vote for manufacturing a completely new impeller from scratch. This is another view of another crack, not as bad as the first, but nonetheless, if you trace it down, you can see the crack does go all the way to the base and in fact intersects with the hole at the bottom. Now, I'm not sure what those holes do. There are two pairs of them. Maybe they allow air to go through, or possibly could even eliminate like a howling sound that may be generated by air trapped in the impeller blades, almost like an air raid siren. So that could be what it does, but I'm really not too sure. But in any case, the location of those holes accurately will have to be determined if I'm going to make a new one. So that will require very careful measurement and looking at what materials are on hand. This is a bottom view of the impeller itself, and you can see quite clearly the shiny spots are where the damaged impeller was rubbing against the underside of the blower mechanism on the tractor. So that was hitting against the bottom. So it's not flat at all, which means that the central hub, which mounts onto the shaft, and the base of the impeller are no longer perpendicular. So that's going to have to be addressed. So I have to actually measure and check just how far off that hub and the base are from perpendicularity. That'll determine also just how difficult it will be to bring them back into alignment. This can only be determined by placing the impeller on a known flat base, a datum, which would be datum A, and then seeing how the hub and the impeller base are relative to that. So we'll take a look at that in the classroom. So here are my final thoughts on the thing. So if we're going to do a full repair, that would involve using my oxyacetylene torch and a large rosebud tip to heat up the metal to red hot, and then have a very large flat piece of metal to press it to. It is too large to completely fit on the surface of my anvil, so I'm going to need a block of metal at least as big as the diameter of that impeller itself, and some way to evenly press down the surface onto it so that everything can be brought back into alignment. That probably also means finding a piece of shafting to put through the central hole and then bend it back into alignment. So there's a lot of intricate work there with big pieces of metal in order to get that thing back into place. The second option, of course, which is making one from new, involves taking very careful and accurate measurements off the existing one and making up a CAD drawing to plasma cut out the new parts and welding one up from scratch. So if we look at what we have learned, we need a flat reference surface first, or datum A, in order to even begin measurements. From that, we need to figure out our other important datums. I think B would most likely be the center of the hub. A shaft running through the hub would be datum B, because remember, in order of importance, we want to figure what is most important about the part. One, that it is flat, and two, the shaft running through it, which mounts the rest of the machine. So that shaft, we'll have to check that central shaft for its perpendicularity to the base of the impeller. Second things we'll look at are things like the tolerance of angles between all six blades, the perpendicularity of those blades to the base of the impeller, and one we haven't looked at yet, but which is important, is concentricity, which is how is the center of the hub lined up, say, with the edge or diameter of the impeller itself. So that hub needs to be accurately aligned, concentric with the impeller itself. Otherwise, when it's running at speed, it's going to vibrate very violently. Another one is circularity, which using the CNC plasma cutter will enable us to cut very accurate circles, because if you try to do it by hand, it's just not going to happen. So circularity will become a very big issue if this is manufactured by hand. The CNC plasma will enable us to cut very accurate circles and angles, and the more accurate we are, it reduces vibration. Finally, when the part is all done, this will have to be carefully balanced, similar to balancing a tire or a lawnmower blade, and then either weld on little bits to weigh it properly or possibly grind or drill holes in order to balance this thing correctly. Now, all these things will have to be taken into account when determining how much time it's going to take and the final cost for the job. So these are common issues that you look at in addressing a side job, and how much time and money is it really worth it?